Hello, everyone. My name is Kayla Meissner, and I am the Executive Director of Kentucky Commercialization Ventures. We're excited to welcome you today to our first ever KCV Impact Competition Demo Day. For those of you unfamiliar with KCV, we launched in the summer of 2020 as the newest initiative under Kentucky Science and Technology Corporation through funding from KY Innovation at the Kentucky Cabinet for Economic Development. In partnership with CED, the Council on Post-Secondary Education, the University of Louisville, and the University of Kentucky, we are united as the first ever statewide consortium for technology transfer. KCV is a service organization dedicated to providing commercialization resources to faculty, staff, and students at our 6 regional public universities in the community and technical college system. This spring, KCV challenged innovators from our partner institutions to create solutions relevant to the improvement of social, health, or economic conditions of the Commonwealth through our second annual KCV Impact Competition. The goals of the competition were twofold. One, to both encourage ideation to meet some of the state's largest needs, and 2, to highlight the value of innovators from across the Commonwealth. This year, we are thrilled to be able to award $100,000 in total to 7 different innovators from 5 different partner institutions. In addition to our increase of funding from last year, we were excited to receive applications from all of our partner institutions, including KCTCS. For our 2023 Impact Competition, the winners are as follows. For first place, we awarded 2 $25,000 awards to Gil Finley of Kentucky State University for his idea, increasing access of fresh produce in West Louisville food deserts through sustainable production. And Dr. Chris Lennon of Murray State University for his idea, chromatography-free, thermostable protein purification. Our first runner-up was awarded $15,000 to Dr. Zeal Mashawari of Northern Kentucky University for her idea, development of cost optimization tools for a smart integrated renewable energy system. For second runner-up, we awarded 3 $10,000 awards to Dr. Kevin Miller of Murray State University for his idea, flexible electronics and sensors from ion-containing polyosaccharides. Dr. Mahdi Yazdempour of Northern Kentucky University for his idea, development of a gesture-based American Sign Language translation system, and Dr. Sharif Rashad of Morehead State University for his idea, an innovative system for real-time translation of American Sign Language using machine learning. Last but certainly not least, for our third runner-up, we awarded a $5,000 prize to Eric Woolridge of Somerset Community College for his idea, Life Tags, embedded smart chip technology for 3D printed applications. Now we're excited for you all to hear a quick pitch from each of our 7 winners on their innovative ideas.
In West Louisville, access to fresh and nutritious food is a challenge, leaving thousands facing food insecurity and health issues. Introducing a collaborative project led by Kentucky State University, partnering with local growers, corner store owners, and an agritech company. Our mission? Transform corner stores in West Louisville into primary sources of fresh, locally grown produce, with digital displays providing valuable nutritional information. By increasing access to healthy food options and promoting dietary education, we're empowering residents to make healthier choices for a better future. Join us in building a healthier, more sustainable West Louisville. Together, we can make a difference.
Good afternoon. My name is Chris Lennon, and I'm an assistant professor of biology at Murray State University. And my proposal for the impact competition was to develop a method of protein purification that is cheap, simple, and scalable based on technology developed in my lab. So our customers would be biomedical researchers. So these purified proteins are used in all sorts of different processes, and being able to provide these to these customers at a low price would allow them to make more discoveries that are crucial to human health. This would benefit the population as a whole, as well as Kentucky and the local community through the potential development of a company to produce these proteins. Thank you.
Imagine a world where rural communities have access to affordable and sustainable energy solution. That vision is becoming a reality with cost optimization tool for smart integrated renewable energy systems, or CIRUS. This web-based tool is a game changer for rural communities in Kentucky and beyond. It optimizes renewable energy resources to meet basic needs, taking into account energy requirements, available resources, and budget constraints. It goes just beyond electricity, considering cooking and domestic requirements as well. The primary beneficiaries of this tool are the rural communities themselves. By harnessing local available resources such as solar, wind, water, biomass, they now have access to reliable and affordable energy. This has a profound impact on their social and economic development, improving the quality of their life and fostering sustainable progress. By promoting the use of renewable resources and reducing the dependency on traditional sources, we are taking a significant step towards a greener and a more sustainable future. Thank you.
Hello, my name is Kevin Miller, and I'm a professor in the Department of Chemistry at Murray State University. I'm here to give you a brief overview of our recent discoveries in ion-containing polysaccharides, which could be used in flexible electronics, sensors, and other membranes. This work is in collaboration with Dr. David Salas de la Cruz from Rutgers University Camden and is supported in part by the National Science Foundation. In short, we've taken cellulose and chemically transformed it into conductive materials which can be manufactured as fibers or membranes. Cellulose is a sustainable non-conductive material and is a direct product of forestry, cotton, and hemp, all three of which are commercial products in the Commonwealth of Kentucky. The global cellulose market, which includes pulp, fibers, paints and coatings, nanocellulose, and other specialty applications, is projected to exceed $300 billion by 2026. The discovery of new materials from sustainable resources is the key to a cleaner, more cost-effective future. And Kentucky has the chance to be at the forefront of this push to create new electronic materials from sources which are renewable. In this short video, you can see how a piece of our material can be molded into any desired shape, in this case, a helix. The material is first wrapped around a glass rod and held, followed by a brief period of heating and then cooling. The material is then released and will hold the desired shape indefinitely. It can then be returned back to its original shape by simply reheating it. This process can be repeated several times without any detriment to its mechanical or conductive properties, thus making these materials reprocessable and reusable. Given our preliminary research, we believe that these materials could be utilized in two marketplaces of interest to Kentucky. First, these materials can be cast as thin films and used as conductive separators in batteries or as membranes in fuel cell applications. Secondly, thin fibers can be spun of these materials, which could be used in the creation of masks for the capture of carbon, for example, carbon dioxide, or biological entities such as viruses or proteins. This could be critical for our mining industry in eastern Kentucky. Murray State University has a variety of resources available to help support this work, including an array of state-of-the-art instrumentation in the Polymer Materials Science Laboratory and the newly established Fuel Cell Laboratory. Our partnership with Rutgers University Camden will allow us to understand the relationships that exist between material structure and properties in order to best fit market needs through their new master's program in chemistry and molecular technology. Thank you for your time.
Hello everyone, I hope you had a wonderful day. I'm Dr. Yazdanpur, Assistant Professor and Program Coordinator of Mechatronics Engineering Technology at Northern Kentucky University. Thanks for giving me the opportunity to talk about our new project, Gesture-Based American Sign Language Translation System. But before that, I would like to express my sincere gratitude to KCV for their support and encouragement. What's the problem? According to the World Health Organization, over 5% of the world's population, over 360 million people, experience hearing loss. According to the studies conducted by the National Institute on Deafness and Other Communication Disorders, approximately 9 million people in the US are either functionally deaf or have mild to severe hearing loss. The Kentucky Commission on the Deaf and Hard of Hearing released a statistical demographics report that shows nearly 723,000 or approximately 16% of Kentuckians are deaf and hard of hearing. These people use a system of communication using visual gestures and signs called sign language. There is no universal sign language. There are more than 300 different sign languages in use around the world. American Sign Language, or ASL, is a complete natural language that serves as the predominant sign language of deaf communities in the US. This visual language is expressed by facial expressions as well as movements and motions of the hands and all fingers. The problem is difficult for non-signers to understand this conversational medium without prior knowledge of sign language. What is our solution? We developed 3D printed soft robotic gloves and gesture-based translation interface to turn American Sign Language into text and speech in near real time. This project aims to develop an accessible, low-cost, and easy-to-use solution to help individuals who are deaf or have a speech impairment problem to communicate directly to non-signer people who don't know American Sign Language. Or wearable robotic gloves are completely 3D printed using flexible filament. We use 3D scanner to scan the user's hand, and then we can develop a customized glove for each user. Our interface is also robust and accessible for all users. Here you can see our first prototype. The key idea of our proposed approach is using combination of different sensors to enhance tracking and gesture acquisition, and also using machine learning techniques for signal processing, feature extraction, and classification. Thank you.
Hi, my name is Sharif Rashad and I'm working on this project with my student John Jenkins. The main idea of this project is to build an innovative system for real-time translation of American Sign Language using machine learning. There is a need to build a system that is easy to use, accurate enough to convey the meaning of captured sign language, adaptable to the individual, and usable in everyday life. The proposed software system will utilize motion controller to capture hand movements to build machine learning models that can be trained to accurately recognize the American Sign Language symbols being signed in real time. A recurrent neural network algorithm will be used to build a deep learning model for translation of complete sentences. This system will have a wide range of applications for healthcare, education, gamification, communication, and more. The proposed system has the potential to make a significant impact in Kentucky and the world by improving communication, enhancing education, providing job opportunities, promoting accessibility, and fostering innovation. The proposed method doesn't require the user to wear a sensor of any kind and doesn't require any physical contact with the system for user input. This proposed idea addresses an important need for a new method of gesture recognition that is easy to use as voice recognition is today. Thank you for supporting this project.
Hello, my name is Eric Woldridge, and I'm a licensed architect and engineer, as well as a professor and director of the Additive Manufacturing Center of Excellence at Somerset Community College. And I'm glad to introduce you to the LifeTag. The LifeTag is a 3D printed smart device with an embedded NFC tag that allows users to store and access various types of data. The need for carrying multiple different devices and having to keep them charged can be cumbersome and problematic. The LifeTags, however, provide a low-cost, easy-to-use, and customizable solution that aims to eliminate these problems. And the LifeTag is for anyone who needs to store and access various types of data on a daily basis, such as business professionals, students, and outdoor enthusiasts, to name just a few. The LifeTag reduces electronic waste by eliminating the need for multiple devices, promotes convenience and efficiency, and enhances productivity. And the LifeTag also provides fast and easy data changing capabilities, allowing users to tailor the device to fit their specific needs and eliminate the need for charging, as it is a powerless device. So thanks for watching and checking out our product. And we would also want to say thanks to all those who put this award and opportunity together. The reviewers, the one who are sponsoring and managing. This is a great opportunity for us here in the lab and also potentially for Kentucky. And we appreciate the chance to be part of this process. We'll be using the funds to take it sort of to the next level and kind of see how we can improve the technology, the market fit, and just get that ball rolling. And let us know if you have any questions. Feel free to reach out. We'd love to talk to you about the product and see what kind of innovations we can put together and make this into a reality. Thanks again, and we'll see you.
As you all can see, we had some great ideas this year from incredible innovators from across the state and are excited to see where they go with this funding. A big thank you to all that participated on the review panel to provide recommendations on winners. This was no small feat, and we sincerely appreciate the time they volunteered. Thank you all that have joined for attending our first annual demo day. If you have any questions about any of the projects, please contact us at kcv@kstc.com. And if you'd like to stay in the know about KCV programs and successes, please sign up for our newsletter through the link in the chat. Have a great rest of your Friday and weekend, everyone.